So let's find the missing measurement of these similar figures. Here, we want to find the value of x, which would be the measurement of this side. And we've been told that we're working with similar figures. That means that the three angles of this triangle are congruent, or the same, as the three angles of this triangle. And in addition to that, since we have similar figures, that means that corresponding sides are proportional. So let's use this information to help us find this value of x. In order to do this, let's take a closer look at those corresponding sides. Let's create ratios from those corresponding sides. Well, in order to do that, we need to identify corresponding sides. So let's do that first. Let's start by taking a look at this side, side AC. Let's see if we can find the corresponding side to side AC. In order to do that, take a look at the two angles that sit adjacent, or right next to that side. Well, here we have side AC, and here we have an angle that measures 48.4 degrees, and another angle that measures 38.6 degrees. Now take a look at our other triangle. Find those same two angle measurements, 48.4 degrees and 38.6 degrees. The side that sits right next to those two angles is the corresponding side. So this side right here is the corresponding side. That is the side DF. So side AC corresponds to side DF. Now let's take a look at their measurements. Side AC has a measurement of 8, and side DF has a measurement of x. That means that a measurement of 8 on the smaller triangle corresponds to a measurement of x on the larger triangle. Perfect! Now let's find another set of corresponding sides. We follow the same process. Let's take a look at this side now. Side BC. Well, if we look, BC is right next to the angles that measure 93 degrees and 38.6 degrees. Taking a look at our other triangle, we see those same two angle measurements, and the side that sits right next to those. That is the side EF, our corresponding side. And if we take a look at their measurements, side BC has a length of 6, and side EF has a length of 12. So, a measurement of 6 on the smaller triangle corresponds to a measurement of 12 on the larger triangle. Now we have one more set of corresponding sides. Here, sides AB and DE correspond to one another. But take a look at side DE. We were not given the length of this side. So, that set of corresponding sides will not be of much use to us in finding this value of x. But that's okay, because we already have two sets of corresponding sides with their measurements. And one of them contains that variable x that we're trying to solve for. So let's turn each of these sets of corresponding sides into a ratio. One of the ways we can do this is to write it as a fraction. So let's take these measurements and write it like this, 8 over x. Now we want to set up a fraction the same way with this relationship. Here, if we look, the measurement of 8 was attached to the smaller triangle, and the measurement of x was attached to the larger triangle. So we need to put these values in that same order. 6 was the measurement that came from the smaller triangle, and 12 was the measurement that came from the larger triangle. So we want to put 6 over 12. And now we have these two ratios. Now remember, we're working with similar figures. So that means that corresponding sides are proportional. That means that if we take the ratio of corresponding sides, that value of each of the ratios will be the same. That means that 8 over x has the same value as 6 over 12. In other words, these are equal. And look at what we've created. We now have a proportion that we can use to solve for x. So, in step number 3, we need to use the means extremes property of proportions to solve for x. So, we take 8 times 12, and we get 96. Then, we take x times 6, and we get 6x. In order to get x by itself, we need to divide by 6 on both sides of the equal sign. Over here, these 6's cancel out, and we're just left with x. When we take 96 divided by 6, we get 16. And look, we now have a value for x. We have found that missing measurement. X is equal to 16. And if we think about it, this makes sense. If we have similar figures, that means we should be able to take a measurement from one of the triangles and multiply it by a constant, which is called the scale factor, and we should get the measurement of its corresponding side on the other triangle. So take a look at 6 and 12. Those are corresponding sides. If we take that measurement of 6 and multiply it by 2, we get 12, the measurement of the corresponding side. This constant of 2 is the scale factor. So we could take another set of corresponding sides and multiply using this scale factor. So for instance, take 8 and multiply it by that scale factor of 2. And look at what we get, 16. The value that we just found for x, that value of the corresponding side. So here we used our knowledge of similar figures to help us find a missing measurement. And we found that missing measurement to be 16.